Today we're going to run through a complete demo of crawling any website with a combination of traditional crawling techniques and an LLM. The reason you'd want to use an LLM in the first place is because often crawlers can be pretty fragile tools. The reason being that we're scraping unstructured, undocumented data that could change at any point in completely unpredictable ways, and that would cause the scraper to break. So instead we can just offload all of that work to an LLM, just pass it all of the HTML and let it return the selectors back to us. So we can do things like fill in forms, click elements and all that kind of stuff. So by the end of this video, we'll have a complete crawler that can go to amazon.com, search for anything in the search bar. In this case, we'll just search watches. It will then look through all of the results, click into the results, and then scrape this page, returning the title, the price, and the rating as well. We're going to do all of this with an LLM rather than writing any code that specifically looks for any selectors on the page, which means the crawler is going to be really, really resilient and can pretty much be used on any website. It's not just going to be specific to a website like amazon.com. Today, we're going to be writing all of our code in TypeScript. If you know JavaScript, then it's pretty much the same thing. We're going to be using a tool called Crawlee, which is also based on Playwright. And then we're also going to be using one of OpenAI's models to actually parse the HTML and do all of the heavy lifting stuff for us. The reason why the model is super important in this case is purely down to price. Now, a lot of the time, the pricing is based off per million tokens. And if we look at a bunch of different models from OpenAI here, let's look at the pricing. Per million input tokens, GPT 4.1, $2, 4.1 mini is 40 cents. And you might think, well, a million tokens is actually quite a lot, so why does this matter? But if we look at a website like Amazon, and I'll go back to the home page, if we just view the page source, this is all of the markup that we would potentially be passing into our LLM. So if I copy this, and then on this website here, we've got platform openai.com/tokenizer. This will tell us how many tokens the text takes up. So for the case of the Amazon homepage, that's 300,023 tokens. That means you'd only have to visit Amazon 3 times to use up a million tokens. So if you was on a model like GPT 4.1, that's going to cost you $2 every 3 times that you scrape Amazon, which is obviously insanely expensive. So we want to try and use a more cost optimized model. And luckily for these kind of situations, you don't need a smart model. You don't need any kind of reasoning or deep thinking. So we're just going to use the cheapest model that OpenAI have available, which is GPT 4.1 Nano. That costs just 10 cents per million input tokens, and it's basically flawless in performing these kinds of tasks. So let's just jump straight into the demo. Now to start off, we're going to be using a tool called Crawlee. Crawlee is a wrapper around tools like Puppeteer or Playwright, and it's just going to help us write crawlers in a pretty straightforward, easy way. So just head over to the Crawlee website. You could do this for both JavaScript or Python. In this example, we're just going to be using JavaScript. And to get started, we just need to run npx crawlee create and then the name of our project. So in our project here, we'll just fire this off, npx crawlee create demo crawler. In our case, let's choose the Playwright crawler, and then the template project will be TypeScript. Okay, so that's generated a new project for us in a folder called demo crawler. So we'll cd into this. And then let's just open this up. We've only got 2 files that have been generated here. We've got main.ts, which just initializes the crawler to start with. And in this case, we're crawling the Crawlee website itself. And then inside routes. So let me just go through and explain, and then we can add all the LLM stuff on top in a second. So first off, we have a bunch of starting URLs. This can be more than one, but in our case, we're just going to start with the Crawlee homepage. And then we initialize our Playwright crawler. We pass to it a router and how many requests that we can crawl in a single run. The max in this case is 20, but of course you can change this number. And then we just call crawler.run and then pass the start URLs. What this is going to do is it's going to visit this page and then return the HTML to us. So inside router here, the HTML will be returned in this default handler. In the initial demo, we're just calling enqueue links, which is just going to say find any link on the Crawlee website and then add that to the queue with the label details, which means all of the links found in this situation would end up coming to this handler because of the detail label. And then we're just going to grab the title and then push that data calling push data, which is available from the callback. Let's see what happens here if we run this npm run start. So the crawler starts, it queues all of the URLs. So it finds every URL on the page which matches this particular pattern. And then once the crawler is finished, inside storage datasets, we have the information that it's crawled. So we've got the URL of the page and then the page title as well. And you can see for each page that it visited, we have all of that information. So we're going to update this initial boilerplate to work with Amazon and using an LLM. Now, the first problem that you're going to face with websites like Amazon.com is that they'll quickly detect that you're a crawler and then present you with something like a captcha. And luckily, you can get around that with tools like Playwright using a couple of extra packages. So we want to install 2 extra packages, Playwright Extra and Puppeteer Extra plugin Stealth. This is going to trick the website into thinking that we're an actual user. So let's install those. Then we can import Chromium from Playwright Extra and then also import Stealth plugin from the Puppeteer Extra plugin Stealth. Now we just have to write chromium.use Stealth plugin and then pass an object into the Playwright crawler called launch context. And on here we'll have launcher and then just pass in Chromium in this case. Now this setup will allow us to search a website like Amazon.com and then hopefully it won't detect that we're a crawler or present us with any kind of captchas. So if we just head back over to amazon.co.uk or .com, depending on where you are, let's just think about what we need to do. The first thing we need to do is find the search input so we can actually type something in. In this case, we'll search for watches. And we also need to find the search button. Once we press search, we'll be on the details page. Then we need to find the link for each of the results. So the link that appears at the bottom of the page here when I hover over. And then once we've clicked into each details page, we then want to grab the title, the rating, and the price as well. So there's 3 separate things that we need there. The ability to search, the ability to find links, and the ability to extract details from a page. So if we head back over to roots, let's start defining this process. So let's just remove this code which was coming from the boilerplate, and instead from this callback we'll need add requests and page. And the first thing you want to do is find all of the selectors to actually make a search in the first place. So we say const selectors equals, and we'll write a helper in a second called find search selectors, and then we'll pass the page into this. The page is where we can actually grab the HTML from, so this is going to be really important to the context that we pass to the LLM. From the selectors, we actually want to get hold of the search input itself. So we'll say const search input equals selectors.search input, and then search button is going to be selectors.search button. Once we have access to these 2, and we won't just yet because we haven't written this function, we can then actually interact with the page. And to do this, we're just going to use standard methods provided by Crawlee. We're not actually going to use an LLM for this part. So we'll say await search input.fill, and then we'll just search for the word watches. And then we just want to submit that search by just clicking the search button. So we say await search button.click, perfect. When that happens, if we type in watches and press search, the page is going to reload with the search results page. So we just need to wait for that load to happen. So to do that, we can say await page, wait for events, and then we'll just say done content loaded, and then just give it a 1-second buffer just in case anything else is happening. Then the next step, right, is to grab all of the URLs. So we'll say const URLs equals await get results URLs, and then we pass page into that as well. Once we have all of the URLs, we can then just add those requests using this method here, which comes back from the callback. So we say add requests. We're going to map this as well. So for each URL, we want to return an object which contains the URL itself and a label of detail. We do this because once it has a label, it means when this URL is added to the queue, rather than coming back to the default handler, it will come back to the named handler with the same name, detail. Once we're in this handler here, we can just leave a lot of this code in place. But the third step we need is once we're actually on a detail page, we need to extract, as I mentioned before, the title, the rating, and the price. So to do this, we'll assume we have another helper that's ready, details equals await get details, and again pass page to that, and then we'll just return the details here. Now we just need to create these 3 helpers: find search selector, get result URLs, and get details. So let's create another file here called called AI helpers, and we'll export each of these. Get details, we'll import the page type from Playwright, then we want get results, and then we want find search selectors as well. So now we can go back into here and import all of these. Get details. And now we just need to implement each of these functions. So first, let's start off with find search selectors. Now, all of this work is going to be completely offloaded to an LLM, and we're going to do that in a pretty repeatable way. So we're going to create a helper function in a second called send message. And send message is going to take the page itself where the actual HTML markup exists. We're then going to take a message, which could be something like find the search input and button. And then we're also just going to pass a format in the shape of a JSON schema. And the reason for this is we want predictable information coming back out of the LLM rather than just free text. So we can parse it correctly, pass it back to our scraper, and just ensure that the scraper runs consistently and predictably. So let's implement now as well this send message helper. So let's create another function here called send message.ts. And to implement this, we're going to need a few different modules. So let's say npm I, we want OpenAI, .env, and also Zod as well. Let's install those. We'll say import OpenAI from OpenAI, import config from .env, and this is so we can load the API key from a .env file in just a sec. We also want to get page, so there's the TypeScript type from Playwright. Then to actually send our Zod schema to OpenAI, we want to import a package called Zod text format from OpenAI helpers Zod. Let's also import Zod schema from Zod, and then we'll just leave it at that for now. First, we'll call config so we can actually load our environment variables. So to do that, we want a file called .env, and in here you want to define a new variable called OpenAI API key, and then just grab your API key from the website. So back in here, we'll define the name of our model. In this case, we're using GPT 4.1 Nano. Then we can define a new instance of OpenAI and pass in our API key. And now we can define the new function. So let's define this function like that. And then we do want to make this async, and we want to accept a bunch of arguments here as well. We want the page, the message from the user, and then the format for the response. For each of these types, page will be page, which comes from Playwright. Message will be a string, and then format is going to be a Zod schema. Now, to actually make the output type of this function match the input type, we just want to define a generic here as well. So here we'll say t extends any, and then just pass t into Zod schema here, and then just leave it at that. Let's grab all of our arguments here, page, message, and format. And now let's create the prompt that we're actually going to send to the LLM. So we say const prompt equals, and then we're going to give it the user message, and then we'll give it the page content as well. So to do that, we just return the promise page.content, which is going to return to us a string, which is going to be the HTML of the page itself. And now to actually send a message to an LLM with a formatted response, we want to say const response equals await OpenAI.responses.parse. So this will return to us a parsed object in the shape of the format that we provide. Let's pass in first the model input. We'll fill this in just a second, and then finally an argument called text, and in that we pass format. And we need to convert it to a format that can actually be used with OpenAI. So we'll use the helper that we imported earlier, Zod text format. Into that we pass format, which is the argument we imported here, and then just give it any text label afterwards. It doesn't really matter at this point. Finally, we can just return response.output parsed. Now this will mean that when we're using this helper, so let's import it here inside AI helpers. Let's import Zod as well, so Z from Zod. We'll say object, and in this case for find search selector, we want a search input, which is a string, and a search button as well. And you'll see, if I just give this an async, you'll see now that the response actually matches the type of the format that we passed in. So we've got search button and search input in that case. So let's go back to send message and just fill in these, and then just fill in this input section. So the first message that we want to pass in is going to be role of system, and then we just need to give the system some personality. In this case, we can just keep it super simple, but obviously add any value here that you need. You're a helpful assistant that is helping me scrape a website. The second message is going to be from the user, and it's going to be the prompt that we defined above. So the prompt is going to be the user message, so just giving instructions on what we need the LLM to do, and then the page content to actually work off in the first place. With that in place, This should be pretty much good to go now. So we can go back into AI helpers and now we can flesh out all of these. So now anytime we want to interact with the page in any way, we're not going to handwrite code to specifically find selectors. We're just going to use that LLM to do all of that work for us. And we can use these helpers that we've just defined to do all of that in wildly varied ways. So for the case of find search selector, let's just add a message here that's a little bit more full on. Return a selector for the primary search input and the search submit button on this page. We only want the selectors, no other text. Then in the format part itself, we can actually describe the information that we want to get hold of. So this could be the selector for the primary search input. And then the second one will be the selector for the search submit button. And then we'll just say, if we don't have a response, throw an error. Now let's do the same for get result URLs and get details as well. In the case of get result URLs, we'll do the exact same thing. The prompt this time will be, this is the search results page. Look at the first 5 search results, return only 1 URL per search result. The link is usually wrapped around the product title and image. Ignore all other URLs. And then we pass it a format just to return an array of URLs. Now there's one thing that will catch you out in this case, and that's that if you look on the search results page here, if I actually inspect this element, you'll see that it's not the full Amazon URL. So it's not amazon.co.uk/SSPA, it's just /SSPA. So we need to make sure that the URL is formatted in a way that the crawler can take it and visit that URL in isolation. So we need to make sure that amazon.co.uk is appended as it would be if we were to actually click the element here. So to do that, we can just get the current page URL. We're just saying current URL equals page.url. And that will just return to us a string. Then we can just loop over all of the URLs. So res.urls or an empty array just in case nothing was returned. Map the URL there. And then from here, we want to return new URL. So URL is just built into Node, and we want to pass in the URL and the current URL. And then from this, .href. So this for us will make sure that the path and the URL, the top level URL, are stitched together consistently. And so we're not going to get any issues in the future trying to visit these URLs. Another thing that we want to watch out for is sometimes the URLs within these tags can be encoded in a way that is more useful for HTML, but not the case for our scraper. So we want to import a new package called HE and just import the types for that as well if you're using TypeScript. And here we just want to say he.decode and then just pass the URL into that and then just import here at the top. And that just means if the URL has something like this, results amp, the ampersand bit, if we decode it, will just end up looking like an and instead. The final one that we need to implement is get details. And for here, again, we're just sending a message onto the LLM in the exact same way we did before. The message this time is, this is a details page. Help me extract the details of the product. So you don't have to be super detailed in this case. The LLM is usually smart enough just to work out what's needed. The format we want in this case is an object called details, which contains the name of the product, the price of the product, and the rating of the product. From here, we'll just return res.details, and then back inside roots, we just need to fix some of this stuff. So we await for this. These are going to be optional. So we say page $, to actually grab the element itself, and do the same for here as well. And that should give us the search input. Again, we just need to await for these. So that should give us the search input, which we can type in the word watches, then we can click it, then we can wait for the details to load, grab all of the URLs, add them to the queue. They'll then get picked up in this handler here, at which point we can grab the page title, grab the details, and then push that data using the method push data. So with all of that in place, let's run this and see what happens. So just make sure you've also added your API key to .env, and then with all that in place, we can just start the crawler and see what happens. So the crawler finds all of the details for each watch that turned up in the search results, and it will grab all of the information for each of these details pages. And then once the crawler's finished, you'll see a new folder that's created here called storage. Inside datasets, we can look to see exactly what the scraper found. So for each watch that was found, we've got the title, the name of the actual watch itself, the price, and the rating. And we have that for each watch that was found. So that's how you write a scraper that is way more resilient than otherwise would be possible without using an LLM. We pass all the HTML to the LLM, let it do the heavy lifting for us, just provide the selectors back so we can just click elements, fill in fields, and extract all of the data that we need. If you like this tutorial and want to see any more like it, let me know what you think in the comments, and I'll see you in the next one.